Welcome back. Today we're going to be doing a practice question for the free response section of the AP Statistics exam. This one specifically is going to be focusing on calculations for the normal distribution. All right, IQ scores are approximately normally distributed with a mean of 100 and a standard deviation of 15. School A only accepts students with top 5% of IQ scores. What is the minimum score required to get accepted into School A? Okay, so for this one, we need students in the 95th percentile, right? This school only accepts students that have the top 5% of all the IQ scores. And so the probability needs to just be limited to 5%, and specifically the top 5%. And so at this point, what you're going to do is on the Z score table, on the Z score table, we're going to look up 0.95. Right? Because if it's the top 5%, that means that it's the other 95% of people who are not accepted to this school, the people who have the bottom 95% of the IQ scores. And you'll see on the chart that the score corresponding to this, the Z score that does correspond to this probability of 0.95, is going to be 1.645. Okay, so that's definitely something to take a look for. Keep in mind that 95% or 0.95 is the probability, so you're going to be looking for that inside the chart, and then the z-score is where it lands, right? So that's going to be on the outside of that chart, so just keep that in mind. Then what we're going to do is actually solve for x, right? I need to know, okay, cool. So how many, like what score do you have to get, right? What's the minimum score required to have 5% of the people have a higher score than you and the other 95% have a lower score than you? What would that score actually be? So for that, we know that the z-score is x minus mu over the standard deviation. In this particular case, we know that we're solving for x, and so I'm going to rearrange this equation to solve for x, and I'm going to get that x is going to be equal to z-score times standard deviation plus mu. In this case, the z-score is 1.645 because that's the score that has the correct corresponding probability. Then we have that sigma, or the standard deviation, is 15. And then we have mu, the mean, is 100, right? These can be just found in the question overall. They've told us what those are. So x is going to be 1.645 times 15 plus 100, which is 124.68. So if we're rounding to the nearest whole number of IQ score, because I'm assuming that IQ score can only be measured in whole numbers, I would say the answer is 125. And so therefore you must have an IQ score of 125 or greater in order to be accepted into the school. So 125 is the minimum to be accepted into the school. Okay, part B says, given that a person has an IQ of over 110, what is the probability that they meet school A's IQ requirements? Or in other words, given that they have an IQ score of over 110, right? Given that they're in that camp, what's the probability that they also have an IQ score of over 125 or greater, let's say? So in order to do that, I first need to figure out the probability of somebody having an IQ score of over 110 and the z-score associated. So what I'm going to do for that one is I'm going to start by finding the z-score. So the z-score, as a reminder, is equal to x minus mu over standard deviation. In this case, x is 110 because that's the score they asked about. They asked, given that someone has a score over 110, so that's what we're going to put in for x. And then minus mu, which was 100, over the standard deviation, which, what was that again? It was 15. So that's going to be 0.6 repeating, essentially, is what that's going to be. Or approximately, if we have to round to two decimal places, we could just say it's about 0.67. And then what I'm going to do is I'm going to look at the z-score table, and we're going to find what probability corresponds with 0.67. So the probability that corresponds there with that is going to be 0.7486. However, keep in mind that's everyone who is here at this point at 110 or less than 110, right? And so, in order to find out the number of or the probability that a randomly selected student has the z score or has a IQ score of 110 or more, we have to find the opposite. So 1 minus this number, and that is going to give us 0.2514. So therefore, approximately 25% of the students overall got a IQ score of 110 or greater. Okay, so what does that tell us, right? Because that wasn't actually the original question. The original question was, given that someone has this IQ score, what's the probability that they also have an IQ score that's over 125, right? That meets the school's requirements. So let's do that full question. So basically, they're asking probability of having the IQ score of greater than or equal to 125, given that it's greater than 110. So in order to do that, I need to do probability of x being greater than or equal to 125 over probability x being greater than 110. Because here's the thing, it's the on the top it's going to be A and B are met, and then on the bottom just B is met, right? So here, if like what this is, it's A given B. Here we have just B is met, and here we have A and B. But keep in mind, if we were to combine these and say probability of that the IQ score is greater than 125 and greater than 110, well, the thing is, all scores that are greater than 25 automatically they meet the other requirement of being greater than 110. And so therefore we can just write this, because if it's in this camp, then it's automatically in the other camp of being greater than 110. The same is not true vice versa. There are several scores that are greater than 110 but not greater than 125. However, all scores greater than 125 or equal to 125 are automatically going to be greater than 110. And so that's why I left that part out, because we didn't need it. Being greater than or equal to 125 implies it automatically is greater than or equal to 110. And then I'm going to use the probabilities from earlier. So we said that it's 5% of the students who would meet the first requirement of being greater than or equal to 125 for their score. And then that would be over the number we just found. And that is equal to about 0.2. And so therefore, the answer is that the probability that a student meets the school's requirements, given that they have an IQ score of at least 110, would be 0.2 or 20%. Okay, so a lot better than before, right? But much better than the 5% chance of all the students, but still not that great a chance. There's going to be a lot of students who have a score greater than 110, but not as high as 125 requirement. Okay, Part C says, if 3 people are randomly selected and they all have IQ scores over 110, what is the probability that at least one of them does not meet the eligibility requirement? Okay, here's the thing. We could go about this in 2 ways. Choice number 1 is we could say, okay, what's the probability that exactly 1 does not meet the requirement, exactly 2 do not meet the requirement, or all 3 of them do not meet the requirement, and we could add those up to find the probability that at least 1 doesn't meet the requirement. Or we could do the opposite and we could say, okay, let's find the probability of the opposite. Let's find the probability that the opposite is true, which is that that all 3 of them do meet the requirement of the 125, and then we can just do 1 minus that probability. That sounds a lot easier to me than finding all 3 and having to add them up. So we're going to take path least resistance here and just do that. Okay, so first let's find the probability that all 3 do qualify. So what's that probability going to be? Well, we know the probability of any one student being eligible, given that they do have the score above 110, was 0.2. So in order to find the probability that all three of them who are randomly selected do meet that requirement, it would be zero point 0.2 times zero point 0.2 times zero point 0.2, and then that would be cubed. And I'm going to do 1 minus that because we're actually looking for the probability of every other scenario, the probability that this isn't the case, that at least one of the students did not meet the eligibility requirements for the school. So let's do that. 0.2 cubed is equal to 0.008, and then we would get 0.992. And so therefore, there is about a 99.2% chance that this is the case, right? That at least one of the students doesn't meet the eligibility requirement. And that makes sense, right? Because even for any given student to meet it is going to be zero point 0.2. It's only a 1 in 5 chance for each student. And here they're saying, let's let that 1 in 5 chance not hit, the 4 in 5 chance of the student not being eligible hit at least one time. It's like, well, that probably is going to happen, right? If we think about it, it seems, oh well, it's very likely that at least for someone, they're going to be that 4 in 5 person that is not going to meet the requirements in the sample here. And so yeah, therefore it does make a lot of sense that it's about a 99.2% chance that at least one person doesn't meet the eligibility requirement from school A. But yeah, as always, if you have any questions, feel free to leave those in the comment section, and we'll see you for the next one.